We are going to start talking about right triangle problems just with our basic sine, cosine, and tangent. These definitions should be familiar to you because we've talked about them. Okay? Before we jump into word problems, we're just going to practice solving a basic right triangle and finding the opposite sides of it, which is what you see down at number 1 here. Okay? So at number 1 down here, if it says solve for the missing pieces, first you have to identify what is the angle that you are being given or talking about. They've given me 25 degrees. This is my angle here. From there, I always label my 3 sides from my 25 degrees. This side over here is my opposite side. I'm given my hypotenuse, which is 14, which means I'm also missing what? Adjacent. If it says solve for the missing parts, this means at the end, we're going to want 3 angles and 3 sides. Okay? If you remember nothing from geometry on triangles, I'll remind you. We have 3 angles here. We have angle A, we have angle B, and we have angle C. We have currently the measurement of 2 of them, and it's very easy to find a third in this case. We have 25 degrees for angle B, and what's the other one we have? 90 for C. We have to have a 90-degree angle to use sine, cosine, tangent. Why is it easy to find angle A? They all have to add up to 180. So if I subtract 180 minus 25 minus 90, that tells me angle A is what? 65 degrees. Okay? So when we say all missing parts, we now have all 3 angles. We also need to use lowercase letters to name the sides here. If you don't remember this part, this is the opposite side from each angle that it goes with. So if angle A is up in the top left, side A is down here. Angle B is in the bottom right. That means this is our side B. And that means 14 is our side C, our hypotenuse. So out of our 3 sides, I currently only have 1 of them. What we use is our sine, cosine, tangents to solve for those. So let's say I wanted to start by solving for B. From my angle, we said that's which side? The opposite. I'm finding the opposite side, and I'm given the hypotenuse. Am I going to use sine, cosine, or tangent? Sine. So I set up sine of the angle. What is the angle? 25 is equal to, do we know the opposite? No, so we say B over what? 14. Okay, before you ever type anything into your calculator on this, you need to solve for the variable that you are trying to find. I'm trying to get B by itself. What do I have to get rid of? The 14. How do I get rid of it? Multiply both sides by 14. Now, what mode should I be in my calculator for this? Degrees. These word problems, always degrees. So in my calculator, I'm going to type in 14 sine of 25 degrees. Typically with these, we round to whatever they tell us, or we round to the nearest whole side. Sometimes they'll tell us that. It just depends. Now, after you find this side, you're going to have some options. All right?
I don't know what this computer is going to be.
If I do 14 sine of 25, my calculator tells me this is about 5.92 for B. Okay? You have options to find side A. You can now choose to use Pythagorean theorem. You have B and you have C. You can use that to find A. You could also use which of our trig functions? Cosine. I'm comfortable myself with sine, cosine, tangent, and sometimes I prefer that to Pythagorean theorem, just in solving. So I would typically set up cosine of 25 is equal to A over 14. Again, solving by 14 or multiplying by 14 both sides will give me side A. So I would type in 14 cosine of 25. That gives me about 12.69 for side A. Any issues with the basic solving? Is this familiar to us from physics?
Yes.
Yes?
Familiar from geometry.
Oh, okay. So some people are familiar, some people not. Am I going too slow? All right. Let's flip to the next page. We're not going to do a ton of these. There's just some vocab we need to talk about. There you go. All right. On the back two, these are our last two that we are going to do together. So we're going to go quickly with this. The two things we need to understand from this are called angles of elevation and angles of depression. Angle of elevation is from the ground looking up. Angle of depression is from the air looking down. It depends on what they say. In this one, it tells us a jet approaching O'Hare Airport in Chicago. The altimeter, okay, that tells you how high it is. In other words, they're telling you this jet is 5,900 feet over the Sears Tower. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. This one is the one that kills everyone, angles of depression. Okay, the angle of depression comes from looking directly across, because we'd assume that the pilot is, looking straight out. Okay, the angle of depression is in here. It is not in the triangle itself. All right? Okay? The key, though, if you remember anything about geometry, is if the angle of depression from the plane looking down is 5 degrees, the angle of elevation, if someone was standing down here looking up, would be the same. They are alternate interior angles. Okay? The key is to not put it in here. That is not 5 degrees. Okay? Do not say that's 5 degrees. Okay, so an angle of depression is always going to be from the air looking down. This time they would like us to find how far is it from the base of the Sears Tower to the end of the runway. What side of this triangle do they want us to find? The adjacent side from this right here, we'll call that our X. Okay, now from this angle, 5 degrees, this is the what side? Opposite. The one we're trying to find is X, which is the adjacent. So am I going to use sine, cosine, or tangent? Tangent. We set up tangent of what? 5, our angle, is equal to 5,900 over X. All right, how many people know how to solve this on your paper before typing it in? What do we do with the X? We switch it with the tangent of 5. Okay? That's the easiest way to do it. X and tangent of 5 flip-flop, which means X is equal to 5,900 over the tangent of 5. There's only 2 ways to solve these. Either the number's on the bottom and you multiply it to the other side like we just saw, or the X is on the bottom and you switch it with the trig. Okay? So in this one, I'm going to type in 5,900 divided by the tangent of 5 degrees. That's going to tell me X is equal to 67,437.3 feet, because that's what they've been labeling here. Does that actually make sense in terms of the problem? Yeah, we're talking planes here. The plane is 5,900 feet above the Sears Tower. Okay, that's 5,000, almost 6,000 feet. You'd think he'd still have a while before he lands. Okay, you're not going to land him right next to the Sears Tower. You have to think about things in context here. If it's planes, we're going to talk a whole lot more feet than if it's a car stopping. Okay, so think of things realistically a little bit. All right. Last one of these, then I'm going to let you get stuff ready for your quiz. On question 3, this one does not give you a picture. So we have to give ourselves a picture. I do not draw complicated pictures here, just FYI. I am not a picture drawer. Okay, we have a building that is 300 feet high, casts a shadow that is 50 feet long. We want to know the angle of elevation. All right, this time they want to know the angle, not the side. This is the first time we've had to solve for one of these. If I would like to solve for my angle, first I figure out where the sides are in relation to that angle. From that angle, 300 is the what? Opposite. 50 is the what? Okay, so I set up what? Tangent of the angle is equal to 300 over 50. Anytime you are solving for an angle, you are going to use the inverse tangent on the right-hand side to get rid of the tangent itself. So this is the first time we've used inverse. This is only when you are solving for an angle. So under your trig menu, you have an inverse tangent button. These typically we round to the nearest degree. This gives me 80.53, which is about 81 degrees.
So how do you directly fit into the house?
You go into your trig menu, and there's an inverse tangent button, and you literally type what I have there on the right-hand side.
So we just type this on
That.
the right. We don't put tangent twice.
Nope.
Oh, okay.
The inverse tangent, essentially what you're doing is getting rid of that there, but you have to do it to both sides. So that's why you see it on the other side.